In this video, you will be introduced to the concept of sets and the different terms used to describe them. By the end of this video, you will be able to define sets, use the element symbol, identify the differences between finite and infinite sets, and know the difference between a subset and a proper subset. What exactly is a set? In mathematics, a set represents a collection of distinct elements, objects, or numbers that share common characteristics. Sets are fundamental tools for organizing data, solving problems, and exploring relationships between elements. Understanding the criteria for a well-defined set and the methods of defining sets verbally, through listing, and using set builder notation is essential in various mathematical contexts. A set in math is a group of similar items that share a common feature. These sets help sort and manage data, allowing big problems to be broken down into more manageable pieces. Furthermore, they demonstrate how different items relate to one another. They are basic tools in numerous mathematical areas, such as functions and probability. Understanding sets is crucial for various fields like science and engineering. For a set to be considered well-defined, it has to meet two main criteria. First, every element within that set needs to be described clearly so there's no confusion about what belongs and what doesn't. Second, there has to be a straightforward rule or property that categorizes the elements in a specific manner. Take the set of all prime numbers as an example. A prime number is easy to identify. It's a positive integer greater than one that's only divisible by 1 and itself. This means each prime number fits our criteria, being both precisely defined and following a clear rule. This makes our prime number set a perfect example of a well-defined set. When we talk about a set being defined by enumeration, we simply mean that we're listing out all the elements of that set clearly and directly. These elements are separated by commas and enclosed within curly braces. It's a method often used when the set has a smaller and more manageable number of items. For instance, the set of 5, 10, 15, and 20 are defined by enumeration because it directly lists all its numbers, giving us a clear picture of its contents. Set builder notation is a concise way to describe a set based on a specific rule or criteria its members follow. It's structured as variable : condition, where the variable stands for set members and the condition states the rule they adhere to. For instance, x such that x is an odd number is an example of this notation. Here, x symbolizes the numbers in the set, and the condition clearly states that these numbers must be odd. This notation provides a compact and clear representation of sets based on specific criteria. Let's think about the set A, which contains prime numbers less than 10. It's represented as a equals 2, 3, 5, 7. In plain terms, this means all the numbers in set A are prime and they're all under 10. So when we look at this set, we immediately understand that the shared characteristic of these numbers is that they're all prime numbers less than 10. Grasping the ways we define sets, whether verbally, by listing, or using set builder notation, is vital in math. One key tool here is inductive reasoning. This method lets us make educated guesses or conjectures based on patterns we observe. So, as we delve deeper into math, we'll often rely on inductive reasoning to make educated assumptions about sets and how they're used. The more we practice this, the better we get at understanding the importance and applications of sets in mathematics. In the world of mathematics, think of an element as a specific member or value that's part of a set. When we want to show an element using set notation, we place it inside curly braces. So, whenever you see a value within these braces, you're looking at an element of a set. When checking if a value belongs to a set in mathematics, follow these steps. First, identify the set you're examining. Next, compare the value in question to the items in that set to see if it's a match. Finally, if it's part of the set, make sure to represent it using the correct set notation, placing it within curly braces. Is the number 5 part of the set 1, 2, 3, 4, 5, 6? The answer is yes. When we look at the set, we can see that 5 is clearly listed among its members. So 5 is indeed an element of this set. In mathematics, using the right symbols for elements is essential to represent sets correctly and to understand the relationships between different elements. Grasping set notation lets us easily determine if a value is part of a set and helps us tackle set-related problems. By sticking to the guidelines given and utilizing the proper notation, you'll be well equipped to handle elements and sets across many mathematical situations. In math, a set is essentially a collection of items or elements. These sets can be broadly divided into 2 categories. Firstly, there's the finite set, which has a specific, countable number of elements in it. Then we have the infinite set that, as the name suggests, contains an endless number of elements, making it impossible to count them all. So whether a set has a fixed number of members or an endless amount, it falls into one of these 2 categories. When working with sets in math, follow these steps to determine their type. First, take a close look at the set and identify the number of elements it holds. Next, actively count these elements to see if there's an end to them, or if they go on indefinitely. Finally, based on your observation, label the set as finite if it has a fixed number of elements, or infinite if the elements seem endless. Let's determine the type of the set 2, 4, 6, 8, 10. Is it finite or infinite? Looking at this set, we see it has 5 specific numbers. Because we can individually count these 5 elements, we can confidently say the set 2, 4, 6, 8, 10 is a finite set. Grasping the difference between finite and infinite sets is key in math. Simply put, finite sets have a countable number of elements, whereas infinite sets go on forever without a set end. If you follow the steps we discussed, you'll be able to quickly pinpoint the type of any given set. Remember, understanding whether a set is finite or infinite is crucial as it impacts many mathematical ideas and how we approach problems. In the realm of set theory, if every item in set A can also be found in set B, then A is a subset of B. We use the symbol a B to convey this. Moreover, if A has all elements that are in B, but B has at least one element not in A, then A is what we call a proper subset of B. And we represent this with the symbol a B. So, it's all about understanding the relationship between the elements of these sets. To determine the relationship between sets, follow these steps. First, look closely at the given sets to understand their contents. Next, check if every item in set A is also present in set B. If they are, then A is a subset of B. Lastly, if B has even just one item that isn't in A, then A is not just a subset, but a proper subset of B. This process ensures clarity in understanding how the sets relate to one another. When we talk about sets, if one set has some, but not all, elements of another set, can we label it a proper subset? Let's use sets D and F to clarify this. Imagine 2 sets. D has the numbers 2, 4, 6, 8, and F has 2, 4, 6, 8, 10. Every number in D is also present in F, but F has an extra number 10 that D doesn't. This means D is more than just a subset. It's a proper subset of F. In mathematical notation, this relationship is expressed as D as a subset, using the symbol for subset of F. In set theory, differentiating between subsets and proper subsets is crucial. A subset includes every element from another set, whereas a proper subset not only includes all these elements but also has at least one more. If you stick to the guidelines we discussed, you'll be able to clearly identify if a set is a subset or a proper subset of another. Recognizing these distinctions is not just theoretical. It's also applied in many math problems and real-life situations.